Hello everyone, my name is Claudio and I'm going to show you the THOR method. That is an efficient instrument in situations where there is uncertainty or lack of data. I am from Universidade Federal Fluminense and I'm going to show you a case study with some great results. Alright? This presentation is based on the article called THOR Method. That is an efficient instrument of situations where there is uncertainty or lack of data. The authors were Fabrício Maione Tenório, Marcos dos Santos, Carlos Francisco Simões Gomes, Jean de Carvalho Araújo, and Gilvan Prachedes de Almeida. Well, the present study here aims to propose an axiomatic evolution of the method called THOR2. This is the introduction, okay? It is based on the analysis of the original algorithm. It was proposed in the evolution, the distinction, in the attributions of weights in the sum of scores as well as the multiplication of the value of the criterion weight by the fuzzy rogue index of all preference relations. This functionality allows that, in the absence of data, to fill in the classification of alternatives and weights in the decision matrix, it is possible to estimate the data and assign a low pertinence value for attributing that data, thus avoiding the elimination of the alternative or criterion due to the absence of the data. In order to validate the pertinence function proposed for THOR2, an analysis of the ranking of alternatives in 3 different scenarios was carried out. In this way, the scenarios were simulated in which there was an absence of data in the original decision matrix. The analysis to the decision matrix is complete and all data is available in this article, observing the impact of the ranking on the alternatives. In all scenarios, the data is used estimated in conjunction with the pertinence function. The ranking was kept in line with the ranking in the initial situation. However, when it was decided to exclude the criteria, the ordering was different from the ordering in the situation of origin. Okay? Well, so here we have the evolution of the method THOR. This evolution is called THOR2. And the introductions shows to the readers that this research is to deal with inaccurate information in multi-criteria decision analysis that has been ongoing over the past few decades. We have a variety of methods to deal with uncertainty, being applied in several areas such as selection, workflow scheduling, prediction, failure mode analysis and effect analysis, fusion, evidence, reasoning, medical diagnosis, decision making, and classification. In many of the approaches, data preference on the values of the attributes and/or compensation weights are required to the most accurate or representative of the decision maker's preferences. Well, however, providing such accurate data is not always an easy task for decision makers, since there may be the inclusion of unattainable attributes to reflect social and environmental impacts. Since not all data are always available, to apply a multi-criteria decision analysis, the MCGA, it is essential to eliminate variants without data or complete the data. And the exclusion of criteria or alternatives, however, often causes important data to be disregarded, impacting the quality of the ordering generated by the decision algorithms, as occurs in traditional multi-criteria decision support methods, such as analytic hierarchy process, the AHP, ELECTR, and the PROMETEE, for example. The following research problems arises. If you do not have all the necessary data, it is a best practice to eliminate the alternative or the criterion or to assign an estimate conditional on a pertinence value. The use of data estimated in THOR2 proved to be an efficient instrument in situations where there is uncertainty or lack of data, since it is not necessary to eliminate the criterion or alternative in question. Thus, the use of THOR2 method appears to be alternative for the decision problems of this type. Alright, so the THOR method. The THOR method uses preference modeling, approaching the French school, utility theory and multi-attribute theory, approaching the American school, to quantify the attractiveness of an alternative to the criterion of a non-transitive aggregation function. Thus, it considers the non-determinism of the weight assignment process and quantifies the non-determinism, replying the process is ordinary of all the other alternatives. Well, Through the use of fuzzy set theory, it is possible to quantify the uncertainty of the process. The method also allows, through the root set theory, to eliminate all the criteria that do not impact ordering the process. In this way, it is possible to infer whether a given criterion is sufficient or irrelevant regarding the ordering of the alternatives. It is understood as irrelevant. The criterion, that is set of data if removed, does not alter the original ordering of the alternatives, in which all the criteria are used. THOR is able to aggregate the weights assigned by different decision makers through the sum of these normalized values. So, here we have 5 steps that the THOR method uses originally. Step 1 is to represent the relative importance to the criteria in the form of a weight. Step 2, establish a preference threshold and a difference threshold for each criterion. 3, establish a discordance. 4, determine the pertinence of the weight values assigned to each criterion. And step 5 finalizes with determining the pertinence of the classification of the alternative in the criterion. All right? Think with me a little. In a scenario of a lack of security or uncertainty in judging the weights and classification of alternatives, a value that quantifies the inaccuracy is assigned, right? So, in this way, the decision maker expresses the levels of certainty for the weights of the criterion for the classification of alternatives through the pertinence indexes. A value with a real scale of 1, is assigned, in which the closer to 1, the greater the certainty in relation to the assigned item, and closer to 0, the greater the uncertainty. If we given two alternatives, A and B, okay, given two alternatives A and B, 3 situations should be considered when using THOR, S1, S2, and S3, let's call here. In using the S1 context, the alternatives have their attractiveness punctuated in situations where a strong preference occurs. Thus, comparing alternatives with the other alternatives, we can identify the criteria with APJB considering the preference threshold, indifference, and discordance, checking whether the imposed condition is satisfied. If it is satisfied, we know that dominates. If the intra-criterion difference is greater than the preference threshold, the comparison is configured as a strong preference. When the intra-criteria difference module is between the values of the indifference threshold and the preference threshold, the comparison is configured as a weak preference, that is APJB. If the intra-criterion difference module is between the negative value of the indifference limit and the positive value of the indifference limit, the comparison is configured as an indifference, and the relations strict preference, indifference, and weak preference are expressed in the equations 1, 2, and 3, respectively. That is represented here in this presentation by the first set of equations, by the side of the blue circle. Followed by the blue circle, we have the equations 4, 5, and 6. That reflects the 3 situations for the alternative to be ranked better than the other. Okay? In the S2 context, the attractiveness of the alternative is scored of situations of strong, the APJB, and weak, AKJB preference. In the S3 context, the attractiveness in situations of strong preference, weak preference, and indifference are pointed out. So, S1 is considered the stricter scenario, while S3 is the most flexible. So this is an example of the use of the THOR method, the original method. Now we have the THOR2. The THOR2 method contemplates an axiomatic evolution of THOR, presenting as a first contribution in relation to THOR a distinction in the attributions of weights in situations of indifference and weak preference. All right? So, the THOR2 method contemplates an axiomatic evolution of THOR, presenting as a first contribution in relation to THOR a distinction In the attributions of weights in situations of indifference AIJB and weak preference AKJB in situations of S1, S2, and S3 are represented. The situations that occur in AIJB bring them with a half of the weight value of the respective criterion, and the comparisons in which AKJB occur carry a proportion between half of the value criterion weight and the total value of the weight. The equation is described here in this presentation. And as a second contribution in relation to THOR that is agreed, in situations where APJB and AKJB and AIJB occur, that the weight of value of the criterion is multiplied by the fuzzy root index, thus downgrading the comparison in function of the degree of the security of the data. The original THOR only considers the multiplication by the index in the situation AKJB, downgrading the gain only in that case. THOR 2, however, will also include the downgrading of the score in situations of strong preference and indifference. In this way, THOR 2 represents a significant contribution in this respect, since all of the uncertainty present in the attribution of the classification of alternatives and weights is quantified. This functionality allows that, in the lack of data to fill in the classification of the alternatives and weights in the decision matrix, it is possible to estimate the data and assign a low pertinence value, degree of security for attributing that data. In this way, the elimination of the alternative of the criterion is avoided due to the lack of data. Thus, even if there is a score gain, the weight is downgraded by the degree of an existing inaccuracy. Here we have the THORWeb.com. THOR Web system was developed at the Military Engineering Institute, the IME, located in Rio de Janeiro, Brazil. The system was implemented and used HTML, JavaScript, Python, and Flash. In the website, you can use THOR 1 or THOR 2. Both of the methods are available on the website. Okay? And helping to compare the results of the methods, and this contributes to the application in more complex problems, with which a greater number of criteria and alternatives are used. The system aims to expand and disseminate of the use of the methods by the scientific community. In the initial screen, the user must choose one of the two methods that is desired, and then you can, in case of a comparison between the methods, the user must run the problem using both algorithms in order to compare the results. So, if you have a complex problem and want to compare the results using the original method THOR and THOR 2, you can access THORWeb.com for free. You don't have to pay anything, and you just have to, if you use this in a scientific article, just cite the authors of the method and the authors of the software. So you can put your problems here and you can compare between the THOR 1 and THOR 2. Here you can use it with any problem that you want, okay? So here we have the methodology that was used in this article, that in order to validate the pertinence function proposed for THOR 2, an analysis of the ranking of the alternatives in different scenarios were carried out, okay? In each scenario, two values from the original decision matrix were discarded and new values were estimated using a random number generation function. So, the analysis aimed to compare the results of the ranking of the alternatives when there is no data with the situation that the decision matrix is complete, all data are available, observing the impact of all of the alternatives. In each scenario, for this purpose, a function of generating random numbers was used to determine the positioning of row and column, or alternative and criterion of the data to be discarded. In each scenario, two values from the original decision matrix were discarded, and then the values were estimated within a range considered feasible by the specialist, with pertinence being attributed according to the security in the allocation of the values to of the respective range. Later, in each of the scenarios, the difference in ordering the alternatives in S1, S2, and S3 was compared. Alright? Here we have the case study. The table 1 summarizes the main technical operational characteristics of the main chips available. Alright? The table 2 presents the alternatives and the criteria used in a study. Each cell corresponds to an alternative shapes classified in its respective criteria. The assignment of the classification of the alternatives of the main utility, secondary utility, AS1W, ASW, and HE criteria was made through an interval scale, where the distance between the values of the alternatives was considered. The classification of the alternatives, weights, preference limits, limits of indifference, discordance for each criterion was attributed through a joint analysis with experts in the field. Weights were assigned of a scale from 1 to 6, using a scale ranging from 1, at least important, and 6 to the most important. Alright? The table 3 shows the pertinence attributed to each weight and classification of the alternative in each criterion. Alright? Here we can see too that the table 3 shows us some pertinence. Alright? Now we have the table 4. The table 4 shows the ordering of the alternatives using the THOR method. Alright? Here we have the ships ordered. The ships are the alternatives, and we have the ships ordered. And the table 5 shows the ordering of alternatives using the THOR method in a more detailed scenario. Alright? In the results generated by the THOR, the existence of 3 groups was found. The first group consists of the alternatives, and the second group consists of the other alternatives, okay? And this, we have the different positions of S1, S2, and S3, okay? The third group consists of the alternatives with F124, which remains in the last position of all types of ordering, okay? And a more detailed analysis was carried out by evaluating an additional scenario composed only by alternatives that make up the first group. For this, THOR algorithm was used. The result can be seen in table 5. Here we have the ordering of alternatives using the THOR method in some different situations, okay? And after that, the THOR was used in another 3 scenarios, with sorting applied to all scenarios worked, okay? Here we have the THOR S1 sorting, here in the presentation that you are seeing right now, but this was used in S2 and S3 too. So the sorting of THOR was used in another situations. As a result, we have the use of the data estimated in THOR this was proven to be an efficient instrument in situations where there is uncertainty or a lack of data, since it's not necessary to eliminate the criteria or alternative in question. The study in this way fills a gap present in decision problems which data are missing in the decision matrix. This is not necessary to eliminate the alternative or criterion. The THOR the use of the estimate data generate the same ranking in S1, S2, and S3, the original situation in all scenarios. The fact that in the THOR the fuzzy rogue index is multiplied by the weight value in all situations causes all the uncertainty of the model to be considered. Right? Here we can see in this slide that the THOR ordering after eliminating the radius of action and crew criteria. All right. In this table, we can see that the maximum speed and radius of action were removed, okay? And there were changes in the ordering of the second compared to the initial situations in another. You can see more details in the article, okay? As a conclusion, we can see that the article aimed to propose an evolution of the THOR multi-criteria decision support method. The evolution presented an axiomatic variation of the THOR method called THOR. After an analysis of the THOR method, modifications were made in the distinctions of the weights in sum of scores for the scenarios of weak preference and indifference. THOR Web helped in the comparison of the results of the methods, also contributing for the application in more complex problems. In this way, THOR proved to be an effective tool to deal with situations with uncertainty or lack of data, with no need to eliminate an alternative or criterion. From now, I thank you for you that watched this video until now, and I put myself for any doubt that may surge, and you can have my contact here. Okay? So much thanks.